So as I was just showing you, we have a block of material, and we have a hole that's starting at one spot in the material on the top. That's the entry hole on the top, and it is exiting material at a different location on bottom. And the path of that bit, of course, has to go between the two of them. So what we're going to look at is this, is we're going to go center of the top hole to the center of the hole on bottom. We're going to call it the entry hole on top and the exit hole on bottom. So from the center of the entry hole to the center of the exit hole, we're going to draw that line. That is the axis of our drill path, the center of the path. And we're going to look at, of course, a dimension this way, which we're going to call the W, the width, a dimension this way, which we're going to call L, the length, and then the dimension we can't see from this angle, this dimension here, which is our thickness. So we've got a width, a length, and a thickness, or a height, if you want to refer to it as a height. So as we said, the first thing we have to do is we have to get this blue axis, as we're looking at it from the top, if this is our table for our drill press, and we're looking at this piece from the top, we have that axis here, the blue axis, center to center. We need to rotate this whole block so that blue axis shifts so it's now lined up perfectly side to side. So it's parallel with the sides of that table. So that angle that it needs to rotate is just going to be this angle right there. So let's look at that box. So going from this corner to this corner, that angle is found on the bottom. If I look at the shadow of that from across the bottom of the box, this right here is R. It's called my angle of rotation. And it's how far, it's the angle we have to rotate this from square in order to make that, the axis of that hole line up parallel to the edge of our table. If I put some numbers in here, let's say this offset here is 0.750 inches. This offset here, our width is 0.600 inches, and our thickness is 1.200 inches. What dimensions do I use to find R? Perfect. Yes, it is part of this triangle right here. And if I look at that triangle, this is 0.75. This is 0.6. Here's my angle R. So how do I find R? What sides do I have of that triangle? Do I have the hypotenuse? No. So that means I'm looking at legs. So I have to know my angle. R is right there. Which leg is this? Opposite. And which leg is this? Adjacent. So of course, the only trig function that uses both legs, tangent. So tangent theta is opposite over adjacent. So we don't know the angle. We're trying to find the angle here. So we're doing an inverse tangent of the opposite of 0.6 over the adjacent, 0.75. Right, 38.66 degrees. So that angle there is 38.66 degrees. So that's how far we would have to rotate this from square. So if I extended this out, this angle here is 38.66 degrees now. Does that make sense? So most of the time that would be accomplished by clamping something parallel here to the table and measuring that angle off of that parallel. So next, we need to figure out how far do we have to tilt the table now. So if we're looking at our drill press from the front side, here's the table. Here's our block. Pretend that looks like a drill. Coming down into it, we've got it lined up side to side, but our hole still looks like this. So we have to tilt that table so that now the hole on that piece is exactly straight up and down. Well, how far did we have to tilt it? Well, you can actually see it right here. The table is now parallel to where the axis of that old hole used to be, right? That angle that it has to tilt is the angle between the vertical and that axis. Well, that would be this angle right up here. That's T, or angle of tilt. To find that, this is where I had warned you yesterday. We have triangles going in all directions. Drawn out flat like this looks exactly the same as this triangle, but it's much different. This one's actually sitting up and down. This is this side here. What's that dimension? 1.20. Yes, this is T that we're looking for. We don't know the bottom of that. The bottom of that is what cuts across the bottom of this triangle, or the bottom of the rectangle down there. We don't need to know that for any reason. This dimension here, the hypotenuse of this triangle, is what we could consider little l. Little l, remember, is our length of cut, the length of that whole path. And if you recall from yesterday, we talked about three-dimensional Pythagorean theorem. We can find that length as the square root of 1.200 squared plus 0.750 squared plus 0.600 squared, right? Our three-dimensional Pythagorean theorem. We have the three: width, length, and height. Does that look familiar from yesterday? You've got a stumped look, Tom. So we've got, remember yesterday we talked about you can take all three directions, this direction, and this direction. Square all three of them and add them together and get that length across the diagonal. Oh, sure. So we've got the square root of 1.2 squared plus 0.75 squared plus 0.6 squared. 1.537 we get for that. Inches. Now we can find T. From T we have this side, which is which side? Adjacent. And the 1.537 is hypotenuse. Adjacent hypotenuse, of course, are cosine. So now we can solve that for theta. So it's going to be the inverse cosine of 1.200 over 1.537. .67 degrees. So that means that this table is going to be tilted at an angle of 38.67 degrees. What do you think? Not terrible. Now, this dimension here, by the way, is one that you quite often are going to want to know anyway, because if you want to figure out how long it's going to take to drill this hole, you're going to have your feed rate, and then of course you got to have your length of cut. That is actually your length of bore for this hole. So what we have here, top view, front view, and right end view. If I label this here as 1.50 inches, what's this here? 1.50, perfect. We're gonna go, obviously we're gonna line those up. Center line to center line, I'm gonna label that 0.8 inches. And then this way, didn't translate real well, but that'd be the same distance as this distance here. We're gonna call that 0.5 inches. So if I draw out this box, obviously my hole goes from here to here. That's my bore. What is this dimension right here? I'll warn you, I'm way out of scale here. There you go, 0.8. That is the front there. So that is the 0.8 right here. This dimension over here would be the 0.5. That would be the right end. This is the thickness, which is the 1.5. So what I want you guys to find, we have to put in that imaginary line across the bottom. I want you to find the angle of rotation there for me quick. I'm going to give you a couple minutes. So what do we use to calculate R? Well, we've got R here as an angle, right? What's this side? That is the 0.5. What's this side? The 0.8. So R is going to be an inverse tangent because we've got opposite and adjacent there. So 0.5 over 0.8. .01 degrees. So we need to rotate it just over 32 degrees, 32.01 degrees. Next, I'm going to have you guys find L, the length of that cut, the length of the bore. I'll give you guys a minute for that. So to find L, it's the square root of perfect. We can do all three dimensions squared. So second square root 1.5 squared plus 0.8 squared plus 1.772 we get. That is inches. The last thing I'm going to ask you to find then, this angle right in here, that angle of tilt. I'll give you a minute. So in this triangle where that's T, what do we know? Well, we know this dimension here is given as 1.5. What else do we know? Perfect. That hypotenuse is L, we just found to be 1.772. So then T is found as an inverse cosine of the adjacent 1.5 over the hypotenuse 1.772. 32.17 degrees. What do you think? Not true? Easier than the last stuff? Okay. Well, there are shortcut formulas for this. I don't recommend memorizing them, but they are there. For calculating R, you can probably guess what that shortcut formula is because we've already used it. R is just the inverse tangent of W over L. And T is the inverse cosine of H over little l, where little l, of course, is the square root of big L squared plus big W squared plus big H squared, right? I'm not big on memorizing formulas. If you look at these, you can see these shortcut formulas are just what we did up above. But if you need them, they are there to fall back on. In your packet, pages 395 to 397. 1 through 9, the odd. There's 5 problems in there for you to work on. Finding those angles of rotation and tilt and length of